I'm wearing my programmer socks because it's chilly. So I totally forgot to commit my changes last night. So I did lose a little bit of work. However, now I have re-implemented the things that I implemented by the end of my last video, which is uh, voxels or blocks that have different structures of voxels within them. And so you can see that the grass is now 1/8 of a unit tall. And I also fixed the overstepping issue. So there's no overstepping on the bottom here. And if I look up, there's no repeating of the grass like you can see underneath a phantom grass block. There's none of that anymore. There still is some path tracing errors. So this is returning blue, it's returning the sky color, even though there's a block there. I'm not exactly sure why that is. And it's already the afternoon when I'm recording this, so I don't really have a plan for the day. I didn't create one, but I'm going to just keep working, see what I come up with, and I will get back to you. If I try to, essentially when I'm walking on this block, it's kind of hard to notice, but you see this block right here, and what's happening is the physics is still one block tall, even though the grass is only 1/8 of a block tall. And so the physics is not responding to the changes that I made to the miniature voxels. So long story short, is I'm going to implement physics for miniature voxels. Okay, so I have an algorithm which builds the physics data with respect to miniature voxels, which is essentially turning miniature voxels into one or more AABBs, or that is an axis-aligned bounding box. So I can definitely show. This is going to be a little code heavy, but it's you don't have to understand the code, you just have to understand what's happening. So for every block or every voxel inside of a block, we set them all as not visited. And then we find the first block that is solid and that has not been visited. And then if this starting position, which we found here, is still in bounds, so it's still inside the block, then we also define an end position as the same as the start position. And then for every dimension, we walk along that dimension and consume solid blocks that have not been visited. So with the diagram, essentially we start at this voxel, then we go to this voxel, then we go to this voxel, then this one, then this one. We consume them. And you can imagine that happens in 3 dimensions, once for each dimension. And then if a block is not solid, we go to the next dimension. And then we mark all the blocks between the start and the end position as visited. Essentially, we moved the end position by consuming those blocks. And then we create an axis-aligned bounding box out of the start and the end position, and then we add that bounding box to the database for this block. And then you can see if I go into RenderDoc, which is a program that allows me to inspect the GPU as my game is running, I have grass right here, which has a ID of 2. It has one bounding box, and then its bounding box is 8 by 1 by 8. That is XYZ. So it's 8 units on the x-axis, 1 unit on the y-axis, 8 units on the x-axis, or the z-axis, sorry. And that is exactly what we saw in the game. And then I also have dirt defined. I don't have stone defined, which is 3. I have dirt defined though, and we can see that dirt is 8 by 8 by 8, which is exactly what we saw in the game. So I'm going to incorporate this data into the physics engine, and then I will be able to show the difference, and hopefully we'll get some amazing results. So you can see the before, I've essentially removed the player's height, and you can see that my head without any height to my body is right around where this grass block starts and this dirt block ends. So actually my head should be down on this grass block below me, but it's not. So then when I incorporate the bounding box, the new bounding box information into the physics engine, after, you can see that my head is now down on the ground. It's on top of this one voxel tall grass block, even though this is only 1/8 of, or these voxels are only 1/8 of the entire size of the block. So you can see I'm looking up at the block now, and my head is down on top of the block. So this is actually 9 voxels tall, or 1.125 meters tall. So this was difficult to implement, and I didn't have too much time today, so this is going to be all I'm going to be able to implement today. Sorry for the shorter video, but if you did like what you saw, please feel free to subscribe, do the like, do the YouTube thing, and I'll see you tomorrow, where I will continue polishing this change to my physics engine. Goodbye.